The scientific method. Research and the scientific method. What comes to mind when you hear the word research? Here's what I think of. Internet, Google, and other search engines, encyclopedias, using the library, experiments, reporting results, reading textbooks, articles, etc., learning something new. A definition. Research is the investigation of a topic in order to gain knowledge and understanding. Research is about asking why and then searching for an answer to that question. Millions of people saw the apple fall, but Newton asked why. Bernard Baruch. How do people conduct research? Research can take a number of different forms. What have you researched in the past? Here's what research looks like in a couple of different fields. Historians study primary sources, newspapers, letters, photos, artifacts, to recreate past events. Applied mathematicians use mathematical concepts to explain real-world occurrences. Examples, using mathematics to predict the weather. Literary critics, historians, study the lives and cultures of authors to gain perspective about the piece of literature. Scientists conduct experiments to gain knowledge of the universe. Our focus today is on how to conduct experiments using the scientific method. What is the scientific method? The scientific method is a step-by-step procedure used to conduct experiments. The 7 parts are: 1. Identify a problem. 2. Gather background knowledge and make observations. 3. Formulate a hypothesis. 4. Conduct an experiment. Collect and analyze data. Form a conclusion. And finally, share your results. 1. Identifying a problem. How do we come up with a problem? There's a few possible ways. Things that fill a need. Example, can we make cell phone batteries last longer? An idea or topic you want to investigate further. Why are pitchers in Major League Baseball getting injured at record rates, for example? The solution of a previous problem created by a new one. Example, the antibiotic cured the patient's cough, but now she's running a fever. Why is this happening? Notice that all of these examples are started in the form of a question. This is key. Find out about good problems to research and poor problems to research here. And the website is being identified there for you. In identifying the problem, a good problem to study is stated in the form of a question, asks who, what, when, where, why, or how about the situation, and is open-ended. That is to say, results are not obvious. A poor problem to study has an obvious answer, is a statement of fact. Example, my phone's battery does not last long. Does not ask a question. Background research. Before diving into your problem, you want to gather some background information. Things to look for include: has anyone researched this topic before? What were their results? Are there any safety concerns that I need to worry about? What should my experiment focus on? Example, when searching for a reason as to why my car will not start, I'm not going to check the tire pressure. Where should I get my information? High-quality sources would be local libraries, ask the librarian for help, textbooks, encyclopedias, Be careful of outdated versions. The Internet. Online encyclopedias, research articles, and educational websites. Poor sources, to be Wikipedia. Use the sources at the bottom of the Wikipedia page. Social media, Facebook and Twitter. Opinion articles in newspapers or magazines. Websites without citation information. Out-of-date sources. Books on computers from 1940, for example. 3. Formulate a hypothesis. What is a hypothesis? An educated guess of the outcome of your experiment based on your background knowledge of the topic. A hypothesis has the form: if I do this action, then this result will happen. Think of the variables involved and single out the one variable you want to test. Since a hypothesis is a guess, there is no wrong answer. Hypothesis is what you think. A hypothesis should be stated in simple terms. Make sure your hypothesis is something you can test, conduct an experiment for. Examples of hypothesis. If I increase the air pressure of my tires, then I will get better gas mileage. If I do not water my plant for a week, then the plant will die. If I listen to hip-hop music, then my heart rate will increase. Non-examples of a hypothesis. Aliens are real. If I pour more Mentos into a larger bottle of soda, then there will be a bigger jet of soda. Christopher Columbus discovered Northern America. Now comes the fun part. Here we design and perform an experiment to test our hypothesis. Some tips for conducting a high-quality experiment. Keep it simple. Only change one variable at a time. Have a control group to compare with. Make the experiment repeatable so others can verify your results. And 2 locations to learn more about independent and dependent variables, and that website is being shown to you there. And then find out what a control group is at this site. Five, collect and analyze data. During and after your experiment, you want to collect data, results, so that you can draw conclusions. It's possible that you may need to rework your experiment if the results are inconsistent. Summarize results using graphs, diagrams, tables, and pictures. Computer programs can help with this. Compare your results with previous experiments done by others and check that your results make sense. For example, if you're measuring the speed of a car, you should never see speeds of 600 miles an hour. 6. Form a conclusion. What conclusions can you draw from the data you collected? Was your hypothesis correct? What effect did altering the variable have on the results? Were there results that you did not expect? What were they? Your conclusion should answer the question you asked in step 1. Is there any work that could be done in the future to improve your results? Were there any errors in your experimental setup? How can you fix them? Share your results. What do you do with your results, graphs, tables, etc.? Share them. You want to share your results so that other people can learn from your work. What would have happened if the Wright brothers didn't share their ideas on the construction of the airplane? How do I share my results? compile results in a poster presentation, make a PowerPoint presentation like this one, write a few paragraphs explaining the problem, your hypothesis, your experiment, your results, and of course, make a YouTube video similar to this one. Now we prepare for your next visit to Clarkson University. In the next visit, we'll be experimenting with wind turbines. Find out a little about wind turbines by watching the video found here. And that link is to a YouTube video. Presentation tips. Effective presentation tips can be found here. This is a Microsoft Office site. Or poster presentation tips can be found here at Northern Arizona University /undergraduate research /poster presentation tips. Now we'll discuss the Fryer model. The Fryer model is a graphic organizer that helps us to study our vocabulary. What you'll see here are basically flashcards. In the Fryer model, you put the word you're defining in the center bubble, put the definition of the word in the upper left-hand corner, put some facts, characteristics about the word in the upper right, put examples of the word in the bottom left, and put non-examples of the word in the bottom right. Here's an example of a Fryer model card. The word being defined, in this case, is prime. The definition in the upper left is a whole number with exactly 2 divisors. Whole number would be 0, 1, 2, 3, etc. In the upper right, you see the characteristics of a prime number. 2 is the only even prime number. 0 and 1, while they are whole numbers, are not prime numbers. And every whole number can be written as a product of primes. Now in the lower left, you see examples of prime numbers. And in the lower right, you see examples of numbers that are not prime, or what we call non-examples. That concludes our presentation.